Students, this is going to cover how to solve an inequality and graph it on a number line. So I would suggest you pause the screen here and go ahead and write down at least the first one, and then we can work on it together. So we're trying to isolate the variable, get the x alone. So in this case, we're looking at this first one. We want to get x alone. So the do and undo steps for this, first thing done to x is multiply by 4, and then the second thing was to add 6. To undo those steps, we would subtract 6 and divide by 4. So the do and undo steps, you don't have to write them out that way, but if you'd like to, you can certainly do that to stay organized. So we're going to do exactly what we said. We're going to subtract 6 from both sides. And the next thing is dividing both sides by 4. So we get x is greater than 1. What this means is that all the solutions for x, everything, must be bigger than 1. So let's take a look at graphing this on a number line. If we have a 1 here, and you can just go ahead and put these down. I just put my value here in the middle, the 1 in the middle. I know it's an open circle because it's greater than 1. And which side are values that are bigger than 1? It would be to the right. So this would be our solution. Those are all the values that are greater than 1. Now remember, when you're reading a symbol, if the symbol is like this is less than. We read it like we read a book from left to right. And this is greater than. The next one we're going to look at is actually a less than equal to. So if you haven't written this one down, go ahead and pause, write it down, and we can solve this one together. So let's take a look. The do steps, again, we're trying to get the x alone. What was done to x first? It was multiplied by a -3. What was done second? Added 5. So to undo those steps, we would subtract 5 first, and then divide by a -3. So that's the way we would undo this. So I'm just going to rewrite that in here so I can go ahead and do those steps. I subtract 5 from both sides. I have -3x is less than or equal to 12. I divide both sides by a -3. Now here's where we need to be careful. If we divide or multiply both sides by a negative value for an inequality, we change the direction of the inequality. So the solution for this is x is greater than or equal to -4. Because we divided both sides by a negative, we changed from less than and equal to greater than equal to. Let's go ahead and draw this on a number line, the solutions. I'm going to put -4 here. To the right would be a -3. To the left, a -5. We want to go ahead and put a closed circle because it's an equal to. It's greater than equal to. That means -4 would be a solution. And this is again saying greater than or equal to, so we're going to go to the right with our solutions. So big thing to remember here is if you multiply or divide both sides by a negative value, you must switch the direction of the inequality. Now this third example, we see an x on both sides of the inequality. So just like when you're solving an equation, we want to collect the variables to the same side. So before I do my do and undo steps, I'm going to subtract 5x from both sides. On the left side, whoosh, gone. We're left with -14 is less than 2x plus 10. You could have just as easily subtracted 7x from both sides, and that would be absolutely fine. Now I'm going to start my do and undo steps. So what was done to x first? Multiply by 2 and then add 10. And to undo those steps, we would subtract 10 and divide by 2. So let's go ahead and do and undo those steps. So we have -14 is less than 2x plus 10. I'm subtracting 10 first from both sides. -24 is less than 2x. I divide both sides by 2, and negative 12 is less than x. Now here we want to go ahead and graph this, and we'll put a negative 12 here. To the right is negative 11. To the left is negative 13. Open circle on that negative 12 because there's not an equal to. Now this says negative 12 is smaller than x. So x has to be to the right. Negative 12 is smaller than the solution, so we'd have to graph it to the right. And you could actually reverse this and write x is greater than negative 12. This large part of the inequality still needs to touch the x. Greater than negative 12. Those are equivalent inequalities.